I believe I'll share the slides again. I am back. Can you hear me? Can you hear me? Okay, so someone can see the slides. That's good. The sound is choppy. What about now? Better. Okay, thank you. Sorry for that. Networking stuff seems to be not an hour thing since I moved to this place. But yeah, so yeah, I hope go back to one or the other if you have any doubts, so you can make exercises, constructions and these things. I hope it helps. Hopefully it doesn't backfire. Okay, so it's like sometimes you can hear me, sometimes you cannot. Sorry for that. I hope you can hear me now. Am I still frozen? Okay, yeah. Okay, it's not getting a smooth start, huh? You can still see the slides, right? Yeah, okay, good. So let me speed up here. So anyway, so yeah, so this is what I wanted to say. I split the key concept of manifold. So you can, instead of bunching up the definition into one big definition, I just split the concept to make it easy for you to digest. Okay, so this is where we are. So for those of you just joining us, the green stuff is the stuff that we have gone through. So we are here. This is the first session of the manifold section. Whether we cover fiber bundles or not, let's see how things go, because our priority is really to get you up to speed to what differentiable manifolds are. So we have gone through topological spaces, and right now we are here. This is the session, the start of the topological manifolds section, and hopefully we'll get to differentiable manifolds as soon as possible. The reason for this is because, as I already, those of you already being with us for since the start of the crash course, this crash course is really like a prerequisite for module 2, which is about Lie groups, Lie algebras, and representation. And as you can see here, it says a Lie group is a group. Most of you already, as a matter of fact, all of you that are on this call, I'm pretty sure you know what a group is. But it is a group that is also a differentiable manifold. Okay, And then it goes on to say a manifold is a space that blah, 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 resembles Euclidean space, blah, 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 these things. Yeah, so this is the key. So a Lie group is not just a group in the algebraic sense. It does have a differentiable structure. It does have a topological structure. So the goal is really to get you to understand what differentiable manifold is. And in theory, once we do that, you know, maybe we can stop the crash course. I know some of you want some extra stuff like fiber bundles, you know, maybe we can go a little bit more, but let's see how it goes. Once we get to, you know, differentiable manifolds, I will make a poll whether you want to stop the crash course here. Maybe I will have another crash course like on other stuff, more advanced topics like fiber bundles and these things. So the objective is really this, to get you here, okay? Before I proceed, let me just check again to see if I'm still with you. Yeah, okay, good. Finger crossed with the network. Okay, so the topic of manifolds is really a central topic in the study of differential geometry, really, and it's also an area that intercepts with the topology. And the genesis of it, you know, I won't waste too much time with this. The thing you can go and read about it. The genesis really started with the Bernard, with the Riemann, you know, in his early work on what is now known as Riemannian geometry, which is a central topic. And Poincaré in his, you know, work that you know, many people consider as the genesis of what is now known as topology. So differential geometry and topology really, you know, manifolds is really an intersection points between the two topics. Okay, they can be studied independently, but manifolds is a topic that brings them together. Okay, let me go back. I hope you got this. So I was saying, even though the genesis started, the formalization of the concept of manifold actually started here, I believe, you know, with Veblen and Whitehead in this paper called The Axioms of Differential Geometry. You can read about this afterwards, so it's not much to think about. But just to say that, you know, these objects, manifolds, have really a wide range of impact in the thing in outside mathematics, in physics in particularly. Okay, so let's go to part A.